Hello everyone, welcome to this math video where we will attempt to understand further about gradient of a line. And this is a quick recall because you all should have learned about this previously in secondary 2. It is a measure of how steep, that means it is the measure of steepness of a line, how steep it is. And not sure that you all have been exposed to this particular formula. The very first thing you all need to take note of is gradient. We usually like to use the letter M to denote it. And y2 minus y1, we usually use the vertical divided by the horizontal. And do take note, x1 and x2 cannot be the same. So this is the formula. And let's take a look at some of the properties of the gradient. If it is going up, then the gradient will be positive. It is and it will be a positive value. If it is going down, then it will be a negative value, negative gradient. And gradient of a horizontal line, the green color line here, is 0. And vertical line, for vertical line like this, the gradient is undefined. Okay, undefined means that if the number is too large for us to assign a number in it. No answer. And here's something interesting, which I'm going to draw a simple diagram here. If there's a straight line, there's point A, point B, and point C. Gradient of AB, gradient of BC, or gradient of AC, they are all the same. This is something important. And if the line is parallel, let me find another interesting color, orange lah. If the two lines is parallel, the gradient are equal to each other. Same gradient, parallel lines. And last point to take note of, as the gradient, this is with reference to point 3. As the gradient of a straight line along a same straight line is constant, it can be calculated with any 2 points on the line. For example, I can use point A and point B to find the gradient of this line. I can also use point B and point C to find the exact same gradient. Okay? With that, we have come to the end of this video for this quick intro on gradient of a straight line. And if you like this video, please feel free to click on the subscribe button. Mr. Ryan Tan here, always happy to share with you how to solve math problems. Okay, well, in this example, part A, find the gradient of the line joining the point A and point B. Gradient. There's the letter M. We usually use the letter M to denote a gradient. And the formula is y1 minus y2 over x1 minus x2. So here, we are interested in finding the gradient of this line. Point A, point B connects each other. So I'm going to call this the gradient of AB. Okay? And this is one habit of mine. I always like to write my coordinates up and down. And this one is my x1, y1, x2, y2. So like that, very easy for me to see. Look at my y. Y1 minus y2. So it's 1 minus negative 2. Do remember, when you minus a negative value, always put bracket. x1 minus x2. So it's negative 4 minus 5. So if I use my calculator nicely, okay, 1 minus negative 2, negative 4 minus 5, this will give me a value of negative 1/3. And leave the answer in exact value, and fraction is the best answer. In this example, part B, we are given the gradient of the line joining C and D. Okay, so again, this is my personal habit. Once I know we are dealing with gradient, and gradient, we usually use the letter M to denote gradient. y1 minus y2 over x1 minus x2. And this is my personal habit. I like to write my coordinates on top and below so that I can easily see the x1, y1, x2, y2, the coordinates neatly, top and bottom. Yeah, that's my personal habit. So now, we are given this. Find K. Well, we've got this. We are given gradient. So why not we just put everything into this formula nicely? Shall we? So the gradient formula, y1 minus y2, 5 minus negative 3 over x1 minus x2, 7 minus k, equal, the gradient is 4 over 5. Oh, so now this becomes an algebra question. So let's do it slowly. 5 minus negative 3, negative and negative will become, 3 over 7 minus k equals to 4 over 5. So 8 over 7 minus k equals to 4 over 5. And I'm going to times the lowest common. Going to times 5. Times 5, so that eventually here can divide off the common factor to give me 4 on one side. Here it will be 5 times 8, 40 over 7 minus k, and I'm going to times 7 minus k, so this whole thing on top times 7 minus k, so that here will be divide off. We're left with 40 equals to 4 bracket 7 minus k. Expand. I will get 28 minus 4k, and I'm going to add 4k on both sides. so that eventually here will be 4k, positive 40 equals to 28. Finishing soon, huh? And going to minus 40 on both sides, so here only left 4k. I will have a minus 40 here. Yes, you are getting close. 28 minus 40, if your mental sum is not very good, can always enlist the help of a calculator. Negative 12. And I'm going to divide by, yeah, 4 on both sides. So I'm left with negative 3. Divide by 4. So that here can divide by 4 to give me the 1k. Yep. In this question, we have a line that is joined by Q and R. And it intersects the x-axis at T. Find the gradient of the line. I got the 2 points. And I've got the gradient formula. So M, as we all know by now, M denotes the gradient. This is the formula, y1 minus y2 over x1 minus x2. And again, this is my personal habit. I always like to write my coordinates out on top and below, so that will give me x1, y1, x2, y2, so that I can see clearly. And well, the gradient of the line, which I don't know, since they use the line, I just use the line, or you can also use MQR as well. So all these are nice presentation skills that you guys should know and should use. y1 minus y2, 3 minus bracket negative 1 again. Every time that you are going to minus a negative value, must put bracket. x21 minus x2, negative 2 minus 6. And with that, I enlist the help of my wonderful calculator. 3 minus negative 1, bracket negative 1, negative 2 minus 6. That will give me negative half. And therefore, this will be my final answer for part A. Okay, so for this particular question, part B, we are supposed to find the coordinates of T. So let's see. Oh, we already have 2 points here, intersects the x-axis at T. So usually I would, like to kind of do some simple sketch. So Q, x is negative 2, y is 3. So somewhere here. R, x is 6 though. X is 6. Y is negative 1. So it should be somewhere here, my R. Okay, so I'm going to use a ruler to just join these 2 lines. And they tell me this line intersect the x-axis at T. So what do you notice? At the x-axis, I don't know the x, so I just called it small letter t. But what is my y? Yep, So this is a very simple fact that you guys need to know. And please do remember at x-axis, the y coordinate is equals to 0. So therefore, I'm going to let t be small letter t 0. And since they belong to one straight line, from the answer from part A, I already know the gradient. And the gradient is gradient of this line QR, already know is -½ okay, and therefore I'm going to make use of this fact to solve it. I'm going to use t, and I'm going to use one of the points here, so I shall use Q then. -2, 3, x1, y1, x2, y2. So applying the equation, not the equation, the formula for gradient, y1 minus y2 over x1 minus x2. So in this case is t minus -2. This will be equals to -½ I put the negative sign on top, okay? So, once I have this, I would be able to get -3 over t plus 2. Negative and negative become positive. -1 over 2. And I'm going to times 2 times 2 so that here can divide off. And I'm also going to times t plus 2 times t plus 2 so that this side here will be divide off, and I'm left with -6 equals to -1 bracket t plus 2. So, well, just do your algebra. -6 equals to -1t and -2. So if you do your algebraic manipulation nicely, you should be able to get t equals to -2 plus 6. So final answer coming up soon. T equals to 4. And this is not what they want. We don't leave our answer like this. They want coordinates of t. So final answer, t bracket 4, 0. Yep, in this question, oh, we are given in the question itself A, B, C, D, and that's a nice diagram for us to use. A, B, C, and D, we are supposed to find the gradient of all the sides. Wow. Okay. Then let's do it then. A. So I always like to do this, but of course, if you guys are already very good in gradient already, you do not have to follow my habit. So in order to find the gradient of AB, this way of presenting is very good. Gradient, M denotes gradient, and this gradient is AB. y1 minus y2, so -2 minus -2 minus -1 over -2 minus 2. So this will give me a value of 1/4. Okay, done for 1. So another part. AB cleared, BC. So I will have my B 2, -1, C is 3, 2. So my gradient for BC would be -1 minus 2 over 2 minus 3. Again, if I press my calculator, and I would be able to get 3. Next, CD. So my C is 3, 2. My D is -1, 1. So my gradient CD will be equals to 2 minus 1 over 3 minus -1. And this will give me a value of 1/4. And the last part, AD. So my A is -2, -2, D is -1, 1. So my gradient of AD will be -2 minus 1 over -2 minus, I always try to write faster. And this will give me 3. So that concludes question part A. Okay, since we are given this particular diagram, might as well use it. So point A will be here. Point B would be 2, -1. Point C, x is 3, 2. Point D, x is -1, 1. So this is what happened. And I'm going to write out the important findings that we have in part A. Gradient of AB is half. So MAB is 1/4, sorry. BC is 3. MBC is 3. This is again 1/4. MCD is 1/4. MAD is 3. So you actually will realize that, what can you say about the 4 sides here? Gradient AB is equal to gradient CD. Therefore, AB is parallel to CD. Since gradient AD is equals to the gradient BC, therefore AD is parallel to BC. So that would be the answer for part B. And for part C, now that I know they are parallel, this is parallel to this is parallel to this, what is the special name given to this? Yeah, parallelogram. That concludes this question.